Hi there, Miss Barber here. This lesson is titled Annuities, Methods of Saving, and Investments. Please take the time now to read carefully the discovery exercise in your student notes. The last column of the table shows the account balance for each $200 deposited at the end of the 8 quarters. Question is, how much would you have total at the end of 2 years if you deposited $200 at the end of every quarter into an investment that pays 12% interest compounded quarterly? Let's look at the table. We note that your investment amount for the first quarter is $200. We've got 0.12 for 12%, and because it's quarterly, we use n equals 4. Note that we put the money at the end of the quarter, so if you put money in at the end of the first quarter, you've got 7 quarters to accumulate. The $200 you put in at the end of the first quarter will have accumulated to $245.97 at the end of the 2-year term. Let's note that the money that you put in at the end of the second quarter will have only $238.81, and that's because it has 1 quarter less time to earn the interest. If we continue, let's note that the money you put in at the end of the 7th quarter earns only $6 interest. And more interesting is money that you put in at the end of the 8th quarter, when you take the money right back out, earns no interest at all. The account balance at the end of the 2 years is the sum of all account balances at the end of each quarter. When you add those 8 sums, you end up with $1,778.46. This sum is called the value of an annuity. We begin with the ordinary annuities. Let's learn some definitions. Our first definition is the word annuity. It is basically a series of periodic payments. Whether you make it monthly, yearly, or quarterly, it is a periodic payment. An ordinary annuity is an annuity in which the payments are made at the end of the payment period. These are the types of annuities we will be working with for this lesson. The value of an annuity is the sum of all the deposits and the interest earned. This is also called the future value of an annuity. Let's learn the formula for the future value of an ordinary annuity. This is the formula you use to compute how much you will have in an annuity at the end of a certain time period. The formula looks like A is equal to P times, and then brackets, and inside the bracket is the set of parentheses 1 plus R over N, that term raised to the N times T, minus 1, and in the denominator is in parentheses R over N. What do these terms stand for? Well, A is the value of the annuity. It is also called the future value. P is for the periodic payment. R is the interest rate. N is the number of compoundings per year. And T is time in years. Don't worry, this formula will be provided for you on every exam we have over this material. Example, a self-employed person has a Keogh retirement plan. If he deposits $7,500 at the end of each year into an account that pays 11.5% compounded annually, how much will be in the account after 25 years? This is an ordinary annuity problem. The first clue that you have is you make periodic payments. That is, at the end of each something, you make a payment. Whereas previously, the problems we worked with simple interest and compound interest had one payment. Annuities, you have multiple payments. Let's identify our formula, and that is the ordinary annuity formula. In this problem, we see that this guy deposited annually, so N equals 1. In this formula, the N becomes 1, the N becomes 1, and the N becomes 1. So when N equals 1, the ordinary annuity formula simplifies to A equals P times, and in the brackets, the sum of 1 plus R raised to T minus 1, and the denominator is R. Let's identify our parts. A, the future value is what we're looking for. The payment is $7,500 a year. The rate is 11.5% expressed in decimal form, and T is the time in years, which is 25. Now let's write that equation with the values in it. That is, we will put in $7,500 for the payment, 0.115 for the rate, and 25 for T. Let's solve. To solve, you work from the inside out, so let's begin with the innermost parentheses. Add the 1 to the 0.115, and that's 1.115. Next, take the 1.115 and raise it to the power of 25. On your calculator, you would do 1.115, pick what looks like a little arrow, 25, and enter. Write the full expanse of the digits on your calculator screen. On mine, I saw 15.2009834. Then we got 7,500, and that's times the difference of the 15.2009834 and 1 is 14.2009834. Still divide that by 0.115. Perform that division in your calculator. Then you get 7,500 times the quotient 123.4868121. The output is approximately $926,151.091. The self-employed person will have $926,151.09 in his retirement account at the end of 25 years. Why is this significant? Because he invested only $187,500. And where did I get the $187,500? Well, he paid $7,500 a year for 25 years. Example, at age 25, you began planning for retirement. The plan: deposit $150 at the end of each month into an IRA, that stands for Individual Retirement Account, that pays 8.4% compounded monthly. How much will you have in the IRA when you retire at age 65? To figure out which formula you need, notice that you do something periodically. That is, you make a payment each month. So in the solution, first identify the formula, and that's for the future value of an ordinary annuity. Now let's identify the parts. You're looking for your future value or your account balance. You're going to make a payment of $150 every month. Your rate of 8.4% in decimal form is 0.084. N is the number of payments you make every year. You do it every month, so that's 12, and T is 40. That's the age at which you retire, 65, minus when you started when you were 25. Now let's put this together into the formula, and we get, for the P, put in 150. For the R's, put in 0.084. For the N, put in 12. And for the number of years, put in 40. Let's solve this. Again, we solve from the inside out. So I'll do the 0.084 divided by 12 first. That result is 007. I will also multiply 12 times 40, which gives me 480. Add the 1 with the 0.007. So now you have 1.007 raised to 480. Let's continue. In your calculator, key in 1.007 power 480, and then write the full expanse of your calculator. The digits on mine were 28.454,16632. Remember to subtract the 1, and so in the next equals, I will have 150 times, and in the numerator, 27.454,16632 divided by 0.007. Continue to use your calculator, and you will get 150 times the quotient, which is 3922.02376. Multiply those two numbers together in your calculator, and it's approximately $588,303.564. So you will have $588,303.56 in your IRA at retirement. How much will you have contributed? Your solution? You contribute $150 every month, so that's times 12 for 40 years times 40. So your contribution is $72,000 over the 40-year period. Part C, how much did you earn in interest, or better, how much will you have earned in interest? Well, your solution is take your future value, which was the $588,303.56, subtract how much you contributed, which was the $72,000, and you will have earned $516,303.56. So over the course of 40 years, you will have earned a little over $500,000. The sinking fund formula. This is planning for future expenses with an annuity. You use this formula to find the deposit P that must be made at the end of each compounding period into an annuity to reach your financial goals. The formula is actually the future value of an ordinary annuity solved for the P, and the letters all stand for the same thing. A is the value of the annuity, also called the future value. P is your periodic payment. R is the interest rate. N is the number of compounding periods per year. And T is always time in years. Example, you plan to buy a $24,000 car cash at the end of 4 years. You will use an investment tool that pays 9% interest compounded monthly. A, what payment will you need to make at the end of each month into this account to reach your goal? Well, the solution is you have to first identify the formula, and again, you're going to make periodic payments. So we will use the sinking fund formula, which is the future value formula solved for the P. Let's identify the parts. You want to know what your payment needs to be. You want to end up with $24,000, so that's the A, that's the future value. The rate of 9% in decimal form is 0.09. You're going to put money in every month, so it's N equals 12, and time T is for 4 years. Let's put that together into the formula. That is, replace the A with 24,000, replace every R with 0.09, replace every N with 12, and replace every T with 4. So now we're ready to solve. Again, we work from the inside out. 0.09 divided by 12 is 0.0075. So every place we had 0.09 divided by 12, let's put in 0.0075. And in the denominator, you have 1 plus 0.0075, and so that'll give us the 1.0075. Furthermore, 12 times 4 gives us the 48. And so that'll be equal to 24,000 times the numerator is 0.0075, and in the denominator, use your calculator to find 1.0075 raised to the 48 and write the entire set of digits you see on your screen. On mine, I see 1.431405333, still have minus 1. Continuing, got 24,000. The numerator is still 0.0075. You subtract 1 from the 1.431405333, and you get 0.431405333. Use your calculator to perform the division of 0.0075 divided by the 0.431405333. My quotient that I got from my calculator is 0.0173850,424. Multiply that to the 24,000 and it's approximately 417.2410176. The required monthly investment is $417.24. If you put that much money into an account that gives you the interest rate stated, you will have the $24,000 you need to buy your car cash. So how much will you have deposited? Well, you will have deposited $417.24 every month, that's 12, for 4 years. And that product is $20,072.52. But you're going to have $24,000. So part C, how much of the account value is earned interest? Well, that'll be the $24,000 you will have minus the $20,072.52 that you invested. And so your interest, you will have earned $3,972.48 of interest to buy your car. In this example, we're going to learn how to read a stock table. So example, use the stock table for Dunkin' Donuts to answer the following questions. Part A, what were the high and low prices for a share in the past 52 weeks? From the chart, locate 52-week high, and that's 84.74. From the chart, locate 52-week low, and that's 38.51. Part B, if you own 200 shares, how much dividend did you receive last year? Well, that's the number of shares you have times the price per dividend. You have 200 shares and locate dividend in the chart. That would be 200 times the dividend is 1.61. So the product of those two numbers is $322. That's how much dividend you received last year. Part C, what is the annual return for the dividends alone? How does this compare to a bank offering 3.25% interest? Yield percentage is what we find, and that's 2.35. So the annual return is 2.35%, and it is lower than the bank account interest of 3.25%. D, how many shares of Dunkin' brand groups were traded yesterday? Volume 100s is the sales volume in 100s. On the chart, it's 1861 multiplied by 100, and the product, 186,100 shares were traded. Part E, what were the high and low prices for a share yesterday? Find high, 70.28, so $70.28, and the low is $66.66. F, what was the price at which a share last traded when the stock exchange closed yesterday? Find the word close, the amount under that, so that's $68.65. And G, compute Dunkin's annual earnings per share. The formula for computing the annual earnings per share is equal to yesterday's closing price per share divided by the P/E ratio. So let's locate those numbers. Yesterday's closing price, $68.65, divided by the P/E ratio, 2620. That's approximately 2.6200229008. So Dunkin's annual earnings per share is $2.62.